Welcome, ladies and gentlemen. This is Mr. Mayer. In this video, we will prove triangle congruence. By the end, you should be able to say, I can use a two-column proof to prove two triangles congruent by the angle-side congruence postulate. So our directions say use a two-column proof to prove the following. We know that our whole triangle here, CTS, is isosceles, and that segment AS is perpendicular to segment CT. Okay, so again, our job is to prove these two triangles congruent. And just a reminder, you always want to start with given information. So this is our starting place, and then our proof statement is what we end with. This is the last thing in our proof. This is the answer. So starting in the table, what we're going to do, let's go ahead and just put the first piece of information. Triangle CTS is isosceles. We know that is true because, again, it was given to us. Now, a very important way to do your proofs, again, using step by step. Use step 1 to help you create step 2. If I know that the triangle is isosceles. If triangle CTS is isosceles, what that means is that there are going to be some congruent sides and some congruent angles. So what I'm going to know here is that in this triangle, angle C is going to be congruent to angle T, because these are the base angles of my triangle. These are the two congruent angles. So in the proof, to write that out, I'm going to say angle C is congruent to angle T. And again, the reason I know that is because I am talking about the word isosceles. It is the word's definition. So it's the definition of the word isosceles. Be careful with the spelling of isosceles. For step number 3, there's another thing that you can do here. Besides having two base angles congruent, you can say that the legs are also congruent. Be sure to label your diagram as well. So I know that this leg is going to be congruent to this leg. So therefore, side CS is going to be congruent to side TS. Make sure we're putting that in our table. CS is congruent to TS. And again, same reason as before, it is the definition of the word we just used, which was the word isosceles. Word isosceles is not going to help us too much with anything else, so I'm ready to move to my other given information, bring that right down, and you can just apply it right here because it was given. So these two segments are perpendicular. Let's make sure we remember what the word perpendicular means. Again, we're using step 4 to help us create step 5. So if I have two sides or two lines that are perpendicular, what this means is that AS is going to be perpendicular to CT, which means that they are creating right angles. They are creating 90-degree right angles. If that is true, that means that this is a right angle in here. I'm putting a little box. And another right angle in here, I'm putting another little box. Now watch, make sure that you're putting this information not only in the diagram, but into the table as well. So I can now see that angle CAS and angle TAS, so CAS, TAS, those are both right angles. What allowed me to say that? What word did I use from number 4 to help me create number 5? The only vocab word we had in number 4 was the word perpendicular. So I'm going to bring this right down, and that's its definition. That's how I knew that this was true. One thing I've been forgetting, let's go ahead and put all the angles and sides. I see that this is a pair of sides congruent, pair of angles congruent, so this is an angle. I see that this is a pair of sides congruent, so this is sides. And now I'm seeing that I have right angles. Now, this is not saying that these right angles are congruent, but hopefully you remember, if angles are right, all right angles are the same size. They're all 90 degrees. So since I have two right angles, I therefore know that those two angles must be congruent to each other. You have to say this part. If you do not say this part, then those angles are not fully congruent in your table. So now I know that this is going to be the same as this angle. These two angles are congruent, and I can say that, well, what's the definition for that? What vocab word did I use from number 5 to help me with number 6? It's no longer the word perpendicular. I used the definition of right angles. That's the reason why those are congruent. So now I have another pair of congruent angles, and here's the question. Is this angle side angle? Is the side included in between the two angles? Well, if I look at these two angles, again, it's per triangle. If I look at these two angles, is this side between them congruent? Is it labeled? It's not labeled. So this is not angle, side, angle. You have to do this separately. I have an angle, and then I have a side. If you did it backwards, that's fine, but the way we say it is alphabetically angle, angle, side. Double check over here, make sure you have the exact same thing, angle, angle, side, and I do. We have enough information. Once you get one of your theorems, then I have enough information to prove the triangle is congruent, so therefore I know. Final step number 7 is that triangle CSA is congruent to triangle TSA, and it has to go in the exact order that the proof asked me to write it in, which it does. And step 7, the reason for that is that angle, angle, side congruence postulate. All right, everyone, thanks for tuning in. Hope to see you soon.